Welcome to our tutorial about curvature. Curvature is an important principle for surface modeling, and it basically describes the deviation from a flat line or a flat surface. The smaller the radius, the higher the curvature. We're able to assign color to curvature values and visually evaluate the smoothness of our surfaces. AutoCAD gives us easy-to-use tools to help us do this. In this lesson, I'm going to take a look at the principle of curvature, and this will help us get a solid understanding of how curvature works and how it applies to surface design and modeling. I'm also going to demonstrate the Curvature Analysis tool. A flat surface has a curvature of 0. An infinitely small radius has an infinite curvature value. Before you think that this sounds too much like quantum physics, let's just demonstrate with some simple examples. I'll create a sphere with a radius of 1 unit. Let me drop in a second sphere with radius 0.5 and a third sphere with radius 0.25 units. Enter to accept. Let's go to the Surface tab, Analysis panel, Analysis Options. Here are 3 tabs: Zebra, Curvature, and Draft Angle. Let's go to the Curvature tab. Here we can specify color mapping. Display style. Gaussian is basically a display style that lets you evaluate both high and low curvature on the same model. The other options are mean, maximum, and minimum radius. Let's stick with Gaussian. A positive value here means that the surface is shaped as a sphere. When the value is 0, it means that the surface is shaped as a flat surface. A negative value means the surface will be shaped like a saddle. Let's click Select Objects to Analyze. Select the sphere, right-click to finish the selection, return to the dialog window. Now let's click Auto Range. The boxes populate with the curvature value. We see that a sphere with a radius of 1 unit has a curvature value of 1. Let's click Clear Curvature Analysis, and now let's check out our smaller sphere. Right-click to finish. Click on Auto Range. The Auto Range tool tells us that our curvature value is 4. Now let's analyze the smallest sphere. Auto Range. It tells us that the curvature value is 16. And let's cancel out of the Analysis tool. Let me pan left to create another example. Back to the Home tab. Activate the Line command. Place our line. Right-click, switch to Arc. Something like this. Another arc. Now right-click, back to line. And right-click and enter to close the tool. Now I'm going to create a similar shape, except I'll do it using the spline command. I'll try to trace the first object by matching the points of the spline to it. And right-click and enter to close the spline tool. Now let's select and move the spline out to its own space, so we can see them side by side. Activate the Revolve command. Right-click, Mode, Surface, Axis of Revolution Start Point and End Point. Now the angle of revolution, 360. Let's activate the Revolve command and do the same with our spline. Select it, right-click, Mode, Surface, Axis Start Point, Axis End Point, Angle of Revolution, 360. Now let's go to the Surface tab. Analysis tab, Analysis Options. Select Objects to Analyze, choose both entities and right-click. Let's increase the curvature display value to 10. Actually, it looks like 5 will be better. Let's try that. And let's click OK. Let's rotate our models. As you can see, the revolve created with the spline has much smaller transitions. Okay, let's return to the Analysis tool. Analysis panel, Analysis Options, Curvature tab, Clear Curvature Analysis, and click OK. Let me bring in a model from a previous lesson. This is from the Patch command tutorial. Let's run a curvature analysis on it. Select Objects, right-click to finish the selection, and click OK. Let's zoom into this multicolored area. Here's an area that needs cleaning. It's a lot easier to see which areas need some work to smooth out the transitions between surfaces when you apply the curvature color scale. One more thing I want to show you in this lesson is the difference between tangency only and a tangency and equal curvature. Let's create some geometry to demonstrate the differences. I'll create a 3-point arc. Something like this. Now let's bring in a line. Right-click and enter to close the tool. Parametric tab. Let's apply a coincident relation between this point and this point. And let's make the arc and the line tangent as well. The tool active, select the two entities to which you want to apply tangency. So now we've got an arc and a line that are tangent to each other, and they also share a coincident point. Let's drop one more line here. Back to the parametric tab. Let's make these two lines coincident at this point. And let's place an angular dimension between the two lines, 90 degrees. Press enter to accept. Now the arc and line are tangent. In other words, this line is normal to the line that originated from the center of the arc. It also goes to the tangency point. So in a nutshell, it connects the center of the arc to the tangency point. Now let's see how tangency and equal curvature work. You'll remember from the beginning of this lesson that a line has 0 curvature. The arc has some curvature value depending upon the arc's radius. We'll go to the Home tab, activate the spline command. Right-click and enter to close it, Parametric tab. Let's apply a smooth constraint between the spline and the arc. Select the first spline curve and the second curve. Let's place a coincident constraint as well between this point and this point. Now you can better see the difference between the line and the arc that share tangency, and the arc and the spline, which share both tangency and curvature. From a practical point of view, if tangency isn't present, for example, between the arc and the line, this line here and the arc, the transition between those two surfaces will be really obvious and abrupt and not smooth. When tangency is present, like between the arc and this line, the transition between the two surfaces is going to be less visible, but it'll still be present. It'll just be smoother. The transition between surfaces created between the arc and the spline, which share both tangency as well as curvature, will be virtually non-detectable. And you'll be able to see how much smoother it looks when you apply some of the analysis tools such as the zebra stripes or the curvature analysis. This concludes our tutorial about curvature.